Good morning to one and all. Myself, Y. Himat Kumar, Assistant Professor, Department of Civil Engineering. So today our topic is ductile detailing for earthquake resistant RC beam column joints. Signing earthquake resistant reinforced concrete beam column joints with ductile detailing is crucial for the structural integrity of the buildings in seismic prone areas. Here I will be providing you with an overview of ductile detailing for earthquake resistant RC beam column joints and relevant data. First one is the introduction. So ductile detailing in earthquake resistant structures involves the use of specific design and construction techniques to ensure that the structure can withstand seismic forces without catastrophic failure. Next one is the materials. The primary materials used in RC beam column joints include concrete and steel reinforcement. High strength concrete with an adequate compressive strength, typically more than 3000 psi, is often used. High quality steel reinforced bars, rebars, with proper yield strength and ductility are essential. Next, coming for the design principles, the seismic design of RC beam column joints follows specific codes and standards such as building code for seismic design. The design should consider factors like earthquake hazard level, soil conditions and building importance. Ductile detailing practices. Ductile detailing practices for RC beam column joints include ensuring adequate lap slices, proper development lengths and the use of confining reinforcement. Lap slice length should meet code requirements to prevent brittle failure. Development length for rebar should be in accordance with code specification to maintain ductility. Transverse reinforcement such as ties or spirals provides confining pressure to enhance the ductility. Next one is the seismic load analysis. Seismic load analysis is a crucial step in designing earthquake resistant structures. This analysis considers the magnitude of seismic forces, ground motion and response spectra. The design spectrum and corresponding response parameters are determined based on the location of the structure. Joints and connection details. Beam column joints are critical areas of the structure and should be designed to accommodate lateral drift and rotation during an earthquake. Adequate anchorage and lap slicing of longitudinal reinforcement in beams and columns are essential. Proper transverse reinforcement in the joint region helps control the development of plastic hinges and improve ductility. Performance-based design. Performance-based design approaches may be employed to assess the behavior of RC beam column joints under different seismic scenarios. Parameters like displacement ductility, energy dissipation and drift limits are used to evaluate joint performance. Testing and quality control. Quality control measures should be in place during construction to ensure that the ductile detailing requirements are met. Non-destructive testing and quality assurance checks can help verify the integrity of the joints. Next one is the research and innovation. Ongoing research in earthquake engineering leads to the development of new materials and design techniques to enhance the ductility of RC beam column joints. Innovative solutions such as the use of fiber reinforced polymers FRP or base isolators are continuously explored in this process. So in the realm of structural engineering, ensuring the resilience of buildings in earthquake prone regions is of paramount importance. The focus on creating earthquake resistant reinforced concrete RC structures has led to the development of specialized techniques with ductile detailing emerging as a critical aspect. This topic deals into the intricate realm of designing RC beam column joints by keeping an emphasis on ductility, a property that enables materials to undergo significant deformation without structural failure. Participants in this learning journey will embark on the exploration of seismic forces and their profound impact on structures. A fundamental understanding of the high strength concrete and steel reinforcement, the primary building blocks of earthquake resistant structure, will lay the groundwork. Familiarity with the design codes such as ACI 318 or other region specific standards will empower learners to navigate the regulatory landscape governing the structural design. Ductile detailing principles can center stage, guiding participants throughout the intricacies of lap splicing, development lengths, and the strategic use of conforming reinforcement in RC beam column joints. The design process extends to considering seismic load analysis, factors in variables like earthquake hazard levels, ground motion characteristics, and response spectra. The journey continues into the heart of joint and connection design, where participants will learn to craft robust beam column joints capable of accommodating lateral drift and rotation during the seismic events. The role of transverse reinforcement, be it ties or spirals, will be explored in depth, emphasizing their contribution to confining pressure and the enhancement of structural ductility. Performance-based design metrics including displacement ductility, energy dissipation, and drift limits will be specified, providing a holistic view of how structures behave under seismic stress. Quality control measures and non-destructive testing methods will be examined to ensure that the constructed joints align with ductile detailing requirements. Thank you all.